Good day. Today we're going to be looking at writing variable expressions, arithmetic sequences. And one of the things that I would like you to remember as you do this is that an expression is like a fragment of a sentence. I would also like you to remember that the expressions that they're talking about is something you already know. When they're talking about writing an arithmetic sequence and the expression for that, if you remember from 8th grade, when you were talking about slope, this is what happened over and over and over again. So let's say slope is the repeated action. So like if I were to say that I ate 2 cookies every week, then every week I would eat 2 cookies. Next week I would eat 2 cookies. The following week I would eat 2 cookies. So if I were to plot that, then I would just say, okay, well, that's 2, and the X would represent the number of weeks, because I could continue making that on forever and ever, or however long I wanted, or I could find out, at how many weeks had I had how many cookies and whatnot. So remember, slope is a repeated action, something that happens over and over again. If you remember, the B was called the y-intercept. And basically the y-intercept is, where did I start the situation? Well, in the situation I just described, I could start this week. And so my y-intercept, or my starting point, would be 0.00 if I were graphing it, because this is week 0 and I haven't eaten any cookies yet. So when we look at this particular IXL, what we're trying to do is we're figuring out this portion right here. So let's go ahead and get started. So we have here, write the expression to describe the sequence below. Use n to represent the position of a term in the sequence where n equals 1 for the first term. All right, so what they're saying is that if we were to draw a table, instead of putting instead of putting x, I would put n. And then here is going to be my output. Now, all of these numbers you see here are the output when the input starts at 1. So I'm going to start 1, 2, 3, 4. Those are my inputs. My output was 96, 97, 98, and 99. Now, hopefully from 8th grade, you'll remember how to find slope. It is the change in y over the change in x. In mathematics, we call this delta y over delta x. So in order to do that, I would think about, okay, well, look at what's happening as I go from 96 to 97 to 98 to 99. Well, I am adding 1. From 97 to 98, I'm adding 1. 98 to 99, I'm adding 1. Now over here, I'm also adding 1. So the change that I see in the range, or my rise, is 1. The change in my run is 1. So therefore, my slope is 1. So I'm going to put that over here, 1. And instead of putting x, I'm going to put n. Okay, that's all well and good. But I have to find out, where was my starting point? Where was my y-intercept? To do that, we know that the y-intercept is where x on the graph is 0, and then y is some other number. So if I back up and I put a 0 right here, and I was adding 1, then I have to think of what was here before I added 1. Well, it would be 95. So my expression would be 1n plus 95. Or I could just put n plus 95. Let's look at number 2. That was number 1. Number 2, we have 1 is 28, 2 is 56, 3 is 84, and 4 is 112. Well, if I'm going from 28 to 56, and remember these are arithmetic sequences, then I'm thinking about, okay, what is my change from 28 to 56? Well, it would be plus 28. And here, plus 28. Plus 28, plus 1, plus 1, and then plus 1 again. So my change in y over x is 28. Now that's n. So let's think about that. So if I do 28 times 1, I get 28. 28 times 2, I get 56, and so forth and so on. Now if I was adding 28, then that means here, to find out what this point was at 0, I would have to subtract 28. So this would be 28n plus 0. But I'm not going to write it like that because it's assumed that if it's not there, that when I graph this, I'm going to start at the origin. So my answer would just be 28n. Here's our next question. We're going from -2 as our output to -1 to 0 to 1. And again, think about what's happening here. You are simply adding 1 each time. So my change in y was 1. My change in x is 1. So therefore, my slope is 1. Now let's think about that. If I do 1 times 1, I get 1. But my output wasn't 1, it was -2. So what would I have to do to get from 1 to -2? Let's draw a number line and see. If I'm at 1, let's say this is 0, 1, 2, -1, -2, -3. Here I am at 1, because 1 times 1 equals 1, but this is -2. So what did I have to add or subtract to get to -2? Well, 1, 2, 3. So let's test it here. If I go 0, what was the number before -2 before I added 1? So let's see. If I'm at -2 and I subtract another one, that gives me -3. So there's a couple of different ways that you can think about this. So we'll do n minus 3. Okay. All right. On this one, we have our outcome is -5, -10, -15, -20. So let's think about that. We're actually subtracting 5 each time. And the change in our input is by 1. So we've got -5n. And if I were to back up to 0, well, what would this be before I subtracted 5? It would have been 0. So my answer would be -5n. Looking at we're adding 1. And how do I know I'm adding 1? It would seem like it's going the other way, but these numbers are getting closer and closer to 0. So this would have been -90. So my answer would be 1n minus 90. at number 6. We're done. The right hand side, what I noticed is that we were subtracting, and this seems to remain constant over here, that we keep adding 1. So our expression that we would write would be negative 92n. But if I multiply negative 92 by 1, I can think, what was this number before I subtracted 92? It was 0. So this would be negative 92n. The following output, 23, 24, 24. So as we can see, the change is plus 1. It's 1. So our slope is 1, so we can write this as 1n. However, if I multiply 1 times 1, I get 1. But this is 23. So what would I have to do to get from 1 times 1, which is 1, to 23? I would have to add 22, or I can think, what was the number prior to 23 that when I added 1, I got 23? That would be 22. N plus 22. Number 8, let's go on. So we've got negative 3, negative 6, negative 9, negative 12. So we know we're subtracting 3. And we still have that. It's a change in negative 3 over 1. Now think of that. So we've got negative 3n. Well, if I do negative 3 times 1, I get negative 3. Negative 3 times negative 2, I get negative 6. So if we think about this, what did this number have to be before I got to negative 3? And it was 0, and we've proven that by what we did when we multiplied. All right, our next one. All right, on this one, let's look at what and see what's doing. Well, we're going from negative 34 to negative 33, so we are actually adding 1. Please excuse that noise, it was my phone. So I know I've got 1n, but if I take 1 and I multiply it by 1, I get 1. But my output isn't 1, it's negative 34. So I have to think, what was this number prior to me getting to negative 34? Well, it was negative 35, because that's what I'd have to do to get to negative 34. From negative 35, I'd have to add 1. So we're going to have n minus 35. Alright, so on this one, as you can see, from 85 to 170, we're adding 85. And if you're not sure what's being added, you could actually take the other route and go, okay, well, what is 170 minus 85? It's 85. So we've got 85n. If we do 85, that's supposed to be a 5. 85n. 85 times 1 is 85. So this number had to be 0 before I added 85. Because 85 times 0 is 0. So this would be 85n. Next we have negative 25, negative 24, negative 23, 2 as our outputs. So we know we're getting closer to 0 on the number line, so we're adding 1. So our expression starts with 1n. Well, 1 times 1 is 1, but we have to get to negative 25. So if I think about this, what was the number prior to negative 25? It was negative 26, subtracting 20. So that would be n minus 26. I have 36, 72, 108, and 144 as output. So I'm obviously adding 36. All right, and let's do this process. So I'm adding 36, that becomes 36n, because it's what's happening over and over again. 36 times 1 is 36, so there's nothing else that I would need to do to get to 36. So I know that 36 times 0 would have been 0, so it would be 36n. So my outputs here are 53, 54, 55, 56. As you can see, we're adding 1, so this would be 1n. And think 1 times 1 is 1, but what would I have to do to get to 53 if I'm at 1. I would have to add 52. So think about that. Is that true? If I'm adding 1, the number prior to 53 would indeed be 52. So this would be n plus 52. Alright, on this one, our output is negative 21, negative 42, negative 63, negative 84. And so I am subtracting 21 from both sides. Not from both sides of the equation. I went back to equations for a minute. I'm subtracting 21 on the output side. And I know that because the numbers are getting further away from 0 on the number line. So let's think about that. That's negative 21 multiplied by n. Well, negative 21 multiplied by 1 gives us negative 21. So there wasn't some place where this started. It started, that's a wrong way to say it. There was not another number higher than 0 where this started. It started at 0. Because if I think about it, if I'm subtracting 21, well, I could add 21 to get to this number. If I add 21 to negative 21, I get 0. Alright, I decided to do something I don't normally do. As you can see right here on the right side, for those of you who want to take it into the 90s, I wanted to see what would happen, so I did some without you. And as you can see here, we're asked to write the expression, which we've been doing, but then we're asked to find the 21st term. Well, nobody is going to expand this for 21 terms, so let me show you how to do it. This goes back to Q7 and Q10 where you actually did substitution. So here we know we're subtracting 11. So our expression then would be negative 11n. Well, let's think about that. Negative 11 times 1 is negative 11. So that means that we didn't do anything here for the plus b. It was like saying plus 0. Because in order to get to negative 11, I would have had to subtract 11. That's how I know that this would have been 0. Well, it asked me for that, so I'm going to put negative 11n. But then it asked me for the 21st term. Remember, the term is your input. So I might as well say this is f of 21 is equal to negative 11. And then where I had n, so f of 21 is equal to negative 11 times 21. That's what we're doing. So I'm going to take a little break over here and I'm actually multiply those. 11 times 21. So that gives me 231. Okay. I'll put 231 right here. Oh, I forgot the negative. Oh my gosh. How did I do that? I don't know. But I just wanted to show you how to do it. I'm not going to do all this all over again to show you that. I'm sure you get the gist. Just don't make a mistake like I did and forget the negative. Okay. See you later.